Welcome you all to session 1 of the chapter Motion in a Straight Line. We make a body to move in a straight line and we study about this, right? So that's we will be learning under motion in a straight line. Before we go with this motion, let us understand what actually a motion is. Okay, the first subheading that you will be learning in this chapter is about motion. What actually a motion is, right? Okay, a body is said to be in motion. When a body is said to be in motion, a body is said to be in motion if it changes its position with respect to time and its what we say here surroundings. If a body changes its position with respect to time and its surrounding, then the body is said to be in motion. Okay, let me consider a car here, right? Okay, for example, the car is at this position. So do remember, whenever we tell about the position of an object, we always speak with respect to a reference point, right? If somebody asks, where did you park the car? Okay, you say that, okay, I have parked the car in bus stand or near the railway station, right? Okay, means you are giving a reference point to them, then only they can understand where actually the car is. You cannot tell him, okay, this much of longitude, this much of latitude, I have parked the car. No, he will not understand. So your friend will understand where actually the car is depending upon your point of reference, right? If you say you have parked the car beside railway station, means railway station becomes what we say here, point of reference. Always the position of an object is with respect to the point of reference. For example, I have parked the car right near Gandhi Circle. So what is this now here? This is the Gandhi Circle, right? I have parked the car near the Gandhi Circle, right? So Gandhi Circle becomes what we say here, point of reference, right? Considering this Gandhi Circle as a point of reference, let me take it as origin, right? Okay, now I will be drawing x-axis and as well as the y-axis now here, right? Okay, then you know, if I am drawing like this, this is a 10 meter, 20, if I am taking 30 here, this is 10, 20 and a 30. What will be the position of the car? The position of the car will be 30 meter along this side here, along x-axis, right? Along east side is 30 meter and 30 meter along north side of the Gandhi Circle, right? So what is its position? 30, 30. Right. So when I call the car is in motion, I call car is in motion if it changes this position, right? Whenever the car moves, for example, the car moves at this position, right? And it comes here. Whenever the car moves, the position of the car has been changed, right? Okay, if I'm taking like this, the position of the car has been changed. For example, it is 40, 50, 60, 70, right? So the position of this car now is 70 along x-axis and 30 along y-axis. What has changed here? Position has changed. If the position of the car is changed with respect to time, right? It takes time to go car from here to here, right? So it takes some time to go there, right? So if there is change in position of an object, then the body is said to be in motion, right? Okay, see here, a body is said to be in motion if it changes its position. Do remember, position is always taken with respect to a reference point, right? One thing what you need to remember here is this reference point may also change, right? For if I say, okay, if somebody has not seen the Gandhi Circle at all, then you can tell him with reference to the bus stand here, right? Okay, that time what happens, you know, this point of reference itself will change here, right? So this will become what we say here, bus stand. That time bus stand will become the point of reference. Earlier Gandhi Circle was a point of reference here, right? If I am considering Gandhi Circle as a point of reference, now bus stand becomes point of reference. If you change the point of reference, again the position will change here, right? If I am taking 10, 20, 30, 40, 50, 60, that time it will become 60 here. And if I am taking 10, 20, 30, 40, 50, it will become 40 and 50. Okay, this position with respect to Gandhi Circle, this is the coordinate with respect to the bus stand. Means in day-to-day life, we speak about the point of reference, then we will be giving our location here, right? For example, if you are in the college campus itself, and your friend asks you, where are you? You say that, okay, I am at near the auditorium. So auditorium becomes what we say here, point of reference. Do you understand? Whenever we explain the position of an object, we always take the point of reference, right? Okay, do understand this. And this point of reference is depending upon you, right? Which point do you take? It depends upon that, right? Okay, now a body is said to be in motion if it changes its position with respect to time and its surroundings. With respect to surroundings, it is changing the position. If a body changes the position, then the body is said to be in motion. For example, this is a duster, right? It has some position with respect to any origin here, any reference point if I take. If it moves, of course, the position changes, right? If the duster changes its position with respect to time, then the duster is said to be in motion. Do remember. So what is motion? A body is said to be in motion when the body is said to be in motion if it changes its position with respect to time and its surroundings, right? Okay, let me take another one state of the body now here, right? A body is said to be at rest, right? A body is said to be at rest if it does not change its position. If it does not change its position with respect to time and its what we say here, surroundings, right? With respect to time and its surroundings, if it does not change its position, right? If the car is here itself, with the passing of the time, if the position has not changed, then the car is at rest. Simple, right? So when is the body is said to be at rest? A body is said to be at rest if it does not change its position with respect to time and its surroundings. Means a body can have two states. Either the body can be in rest or it can be in motion, right? There are two states for a body, rest or motion, right? If it changes its position with respect to time and surroundings, it is called as motion here. If it does not change its position with respect to time and surrounding, then the body is said to be at rest, right? Okay, one interesting fact you need to know here, right? For example, okay, simple, we understood that if it changes the position, then we call it as the body is in motion. If it does not change, the body is at rest, right? But one thing what you need to remember is this motion is a relative concept. What is the meaning of relative concept? Let us take an example and understand here, right? Okay, just imagine you are sitting in a bus here, right? So this is let me take here, this is a bus and you are sitting here, right? Okay, you are sitting at this position. Let me call this as person A, and your friend is sitting at this position. What is the position here? Let me call it as B here, right? Okay, let me take A person and B person. Let me name them like that, right? Okay, and this bus is moving with certain velocity, with certain speed. The bus is moving here, right? Okay, now the question arises here is, if I ask, right, if I ask person A that is person B is at rest or in motion, right? What will be the answer of him? He says that, okay, he's sitting in a bus here, right? Your friend is sitting in front of you here. If I ask you, right, is your friend rest or motion? You say that, okay, he's sitting there, right? He is at rest, because you are speaking with reference to the bus here, right? What happens, you are speaking with reference to the bus, right? So the bus itself will become x-axis and it will become what now here? Y-axis. You are taking bus as the reference. If you take a bus itself as the reference, then the position of the B will not change. For example, the position of the B is 10, 20, 30, 40, right? This is 10, 20, 30. The position of B is 40, 30, right? This position will not change, but bus might be moving. It is the other factor, right? The bus is moving. If the bus is moving, is this position has been changed? No. That time A says that B is at rest, because he is taking bus as the reference and he is speaking here, right? Means for A, B is at rest here. But there is another one friend who is standing outside here, right? He is standing on the ground here, right? For him, if I ask, let me call him as C here. For C, if I ask B, is he at rest or in motion? If I ask him, he says that, okay, the bus is moving and he is also moving, right? He is in motion because for him, B is changing the position. Why? Because he is taking this as the reference, right? He is taking this as the reference frame, right? Earlier, if he is taking this as a reference frame, if this bus moves with a certain speed, of course the position with respect to this frame has changed, and he says that, okay, his friend is moving now, right? If I ask A, he says that B is at rest. If I ask C, he says that B is in motion, right? Okay, let me tell you now here, B is at rest with respect to A. Okay, with respect to A, B is at rest, and B is in motion with respect to C. Means whatever I say, no, the motion or rest, it is a relative concept. It does not depend only upon the body, it depends upon where actually you are, from which reference you are speaking now here, right? Okay, let me tell about this, why motion is relative. Let me explain this now, right? Okay, let me tell you, a body at rest with respect to one observer, may be in motion with respect to another observer, See, a body at rest with respect to one observer may be in motion with respect to another observer. Hence, I can call it as motion is relative. Do you understand? The motion is a relative concept, right? Why motion is a relative concept? Because it may be the body may be at rest with respect to one observer, may be in motion with respect to another observer. That is why the motion is called as a relative concept, right? So do understand, we cannot say, it depends upon where actually you are, from which reference you are speaking. For example, let me take another example to tell that the body is at rest or motion, and let me conclude that the motion is a relative, right? Okay, for instance, let me take that you are standing in front of me here, right? You are seeing this video here and you are sitting, right? With respect to me, you are at rest, right? Okay, I'm standing here and I'm looking at you and you are sitting, right? Means you are at rest with respect to me now, right? For instance, if I jump out of the earth, right? If I go out of the earth and I'm observing you now, are you in rest or in motion? Just think it over. You are in motion. Why? Because earth rotates. As earth is rotating and moving, you are also moving. But actually you are sitting in front of the mobile now here. But for me, for a person who is standing outside the earth, you are in motion, right? For a person in front of you, you are at rest. But for a person who is standing outside the earth and seeing you, imagine that he is seeing you. You are in motion because earth is in motion. Means I cannot tell you are at rest or motion. It depends upon where actually I am here. That is the reason I call motion as a relative concept, right? It may be at rest with respect to one observer, may be in motion with respect to another observer. Thus, I conclude that motion is a relative, right? Okay, now, based upon this, we will be classifying the branches of physics. Okay, let me call the physics, the branch of physics which deals with a body in motion or at rest, we call that as mechanics. Mechanics, right? Okay, what is mechanics? Mechanics is a branch of physics which studies about the body at rest or in motion, right? So mechanics are again divided into two types, right? One is statics, and another one is dynamics. Okay, mechanics, again it is divided into two types. One is statics and another one is the dynamics. Static, the name itself says static, means a body at rest. Whenever we study about the body at rest, that branch of physics is called as statics. Whenever we study, okay, the body, let me make it a body to move, that time if I study that branch of physics is called as dynamics, right? So what is mechanics? Mechanics is a branch of physics which deals with the body at rest and motion, right? Particularly at rest, we call it as statics. If the body is in motion, we call it as dynamics, right? Okay, and this dynamics is again classified into two branches of physics. One is kinematics and another one is kinetics, right? Okay, see here, dynamics, the body in motion can be classified into two again branches of physics. One is kinematics and another one is kinetics. So what is kinematics? It is a study of a body in motion without considering its what we say here effects, right? So without considering its effects, if you study, then that branch is called as kinematics, right? Okay, if you study the effects of force, if you study the effects of motion, then that is called as what we say here kinetics, right? The study of what we say here body in motion without considering its effect, then it is called as kinematics. Considering its effects, we call it as kinetics, right? Okay, this is how even the branches of physics has been classified based upon the body is at rest or the body is in motion, right? Okay, do you understand? That is the reason we concluded that the body is a relative concept. Okay, next, let me go. After studying what actually the motion is, let me go with the next concept, that is the position here, right? Let me speak about what actually the position is, right? Okay, position of an object, position of an object is its location. Position is always its location. Already I told you, it is with respect to what we say here reference point. So what is position of an object? Position of an object is its location with respect to reference points, right? Its location with respect to reference point is called its what we say here position, right? For example, if I am taking, this is a number line, if I am taking, this is 0 here, right? Let me consider this is one of the point of reference here, right? Okay, now this is, let me take it as 10, 20 and 30. Let me take along x-axis now here. Here let me take minus 10, minus 20, minus 30. Let me consider this point 0 as a reference point. Reference point. For instance, let me consider it as a bus stand, right? Okay, one friend is standing at this position now. Let me call it as A now here. Another one friend is standing here. Let me call it as B. If I ask where actually the person A is standing, he says that, okay, I'm standing, right? So at, if I'm taking, this is the distance, if I'm speaking with distance, and it is measured in meter, right? Okay, so this is the bus stand, right? This person has crossed the bus stand about 30 meters and he is standing, right? This person is standing before the bus stand, right? He is not at gone to the bus stand here, right? Before itself he is standing. How much meter before he is standing? He is standing 20 meters before, right? If I ask what is the distance, what is the position of A, if I ask what is the position of A, he says that, okay, I have already crossed the bus stand and my position is 30 meters, right? Okay, that time I can take it as plus 30 meter. What is the position of A? Position of A is plus 30 meter. If I consider, right, crossing bus stand and moving forward as the positive, right, then who is behind that now here, right? Right, let me call it as negative, right? What is the position of A? Position of A is 30 meter. What is the position of B? What is the position of B? Right, the position of B is minus 20 meter. Understood that he has not yet reached the bus stand, right? Right, do you understand? A has crossed the bus stand and B is not yet reached the bus stand. By seeing this number itself, we can understand here, right? So the position of A is plus 30 meter, position of B is minus 20 meters. Means, I want to say, what is position? Position is nothing but location, right, with respect to reference point. So what is reference point? You can choose anything as a reference point, right? The point which helps you to explain your position to anybody who calls you. So that point can be called as a reference point, right? So this is how, right? If I take this as positive, this side will become negative here, right? So to explain this, these all things you require to explain the position. You require the reference point and you require how much distance you are standing from the reference point, right? So till now we studied what actually the motion is, what is rest, why motion is relative, and we studied about the position of the object. Now let us go with the next concept, that is path length and displacement. Okay, let me imagine that your house is at PNT quarters, right? This is your home now here. Let me take from here you want to go to the college, right? So let me consider this house is at PNT quarters, right? You take the KCRD road and you come in a straight line. Then you will be turning at the Lakani hospital and your college bus will be standing here. You will catch the bus here, right? Okay, this bus moves in a straight line and turns near Gandhi circle. This is a Gandhi circle, right? It takes a turn at the Gandhi circle and it reaches the new bus stand here, right? When it reaches new bus stand, again it will take a turn at the engineering college and it will reach to your destination, right? This is your college, right? So you are coming from home to the college. Let me call this home as the initial position and college as the final position, right? Okay, the distance traveled by you throughout this journey, that distance is called as what we say path length. Let us understand what actually the difference between path length and displacement. Okay, let us take what actually the path length is, right? First of all, let us understand what is path length. Path length is the total distance traveled by a body, right? Total distance traveled by a body from initial position to final position. Okay, total distance traveled by a body from initial position to final position is called what we say here path length, right? So if you count how much distance you covered in this journey, that distance covered is called as path length. So do understand, path length is the another word given to distance covered, right? Sometimes in high school you have studied distance covered and displacement, or distance traveled and displacement, all are same here, right? So what is path length? It is the total distance traveled by a body from initial position to final position. That total distance is called as path length, right? So this is the path length covered by you, right? Okay, now what is the meaning of displacement? Do you understand what is the meaning of displacement, right? Displacement, do you understand, it is the shortest distance between initial position and final position. It is the shortest distance between initial position and final position of a body during its motion. What we say here, motion is called displacement. Okay, so do you understand what actually the difference between the path length and displacement? Path length is total distance covered. Displacement is the shortest distance between initial position and final position of a body. So what is the initial position? This is the initial position. What is the final position? College is the final position, right? So what is the shortest distance? Do remember, whenever you take two positions, the shortest distance is always a straight line, right? So any 2 points you take, the shortest distance is always a straight line, right? So which is the distance now here? This is the shortest distance, and this distance is called as what we say here displacement. Do remember, displacement is always along the straight line, it will never change the direction here, right? So path length is the total distance covered. What is the displacement? It is the shortest distance between initial position and final position, right? There may be no road physically between your home to college in this place now, right? So that's why let me call displacement as a hypothetical concept until and unless you travel in a straight line, right? So in day-to-day life we consider path length a lot, right? Usually we will be going with the path length compared to that of displacement, right? If you compare, you will be using path length a lot in day-to-day life, right? So what is path length? It is the total distance traveled by a body from initial position to final position, right? So the shortest distance is called as a displacement, right? So that is the difference. Do you understand here, right? So what is the difference between path length and displacement, right? For example, let me take be now here, right? For example, let me take a mosquito, right? The mosquito is on the table now here, right? The mosquito is on the table. It begins to fly like this, right? It flies and it reaches and sits at this position, right? So the total distance traveled by the mosquito is what now here? The total distance is path length, right? So this is actually traveled by the mosquito, right? Then what is the displacement? For displacement, you don't want to see how actually it traveled and everything, just you want to know where is the initial and final position. If you know two positions, that's enough, right? So it does not depend upon how actually the mosquito travels now here, right? So what is the initial position? This is. What is the final position? This is. Then where is the displacement? Displacement is like this. Do remember, displacement is always a straight line. It is the shortest distance between initial position and final position. That is why displacement has the direction. Path length does not have the direction. Do you understand? Path length may be anything now here, right? So displacement always has the direction from initial position to final position. This is initial position of the mosquito and this is the final position of the mosquito, and this is called as what we say here, displacement. Do you understand this, right? So in short, let me call path length as the total distance traveled, displacement as the shortest distance between initial position and final position. Okay, now let us take what are the differences between these two now here, right? Okay, now let me speak what are the differences between path length and displacement. Let me take them. Okay. First, let me take path length one side, and let me take displacement other side now here. Displacement. Okay. Path length and displacement, right? So this is total distance travel, and this is what now here, shortest distance between initial position and final position, right? Okay, let me take now here, and if I compare these two, one definition you can write like now here. Let me take now here, this is the total distance traveled, total distance covered from initial to final position. Initial to final position, total distance covered. What is displacement? It is the shortest distance. It is the shortest distance between initial and what we say here, final position. Let me differentiate it by definition first now here, right? Next, which has a direction, right? Particular direction. Displacement, yes, it has direction from initial position to final position. It has particular direction. Displacement, path length, it is not having any particular direction. Means, shall I call path length as which quantity? It is a scalar quantity because it has only the magnitude. It is not having a particular direction. But displacement, yes, you have a particular direction. It is always towards the final position here, right? So let me call this is which quantity? This is a vector quantity, right? So displacement is a vector quantity, scalar, and path length is a scalar quantity, right? Okay, now if I'm speaking about a scalar and vector quantity, it has a displacement here. Displacement is a vector quantity and path length as a scalar quantity, right? Okay, and this path length is always, it is always positive, right? It is always positive, right? It is always in the positive direction, right? It has a distance. If you travel with a certain distance, yes, you get a positive number. And we already studied that scalar quantities are always positive, right? Displacement may be positive, negative, or what we say here, it may be positive, negative, or zero, right? If the college is in this direction, if I'm taking this as positive, right? If this is in the opposite direction, we can call the displacement as negative, right? I already told you, if you consider crossing the bus stand as positive and before the bus stand you can take it as negative. In the similar manner, displacement, yes, it may be positive, it may be negative, and it may be also zero. When it is zero, okay, let me speak about that now, right? Let me tell you when the displacement becomes zero now here, right? Okay, now before I go with this, do you understand? It is a scalar quantity and it is always positive. It is positive, negative, or what we say now here, zero. And another thing what you need to know here is this path length depends on path traveled. Yes, path length depends upon path traveled, right? It depends how actually the body is traveling now here, right? I told you how actually the mosquito is traveling. It depends upon the path traveled. Do remember, displacement is independent. It does not depend, independent of what we say here, path traveled, right? Path covered. It is independent of path covered or traveled here, right? So displacement does not matter how actually you are moving at all. Displacement matters only initial position and final position. That's why let me call displacement. It is independent of path travel. Path length, yes, it depends upon the path travel. So these are some of the differences between path length and displacement now here, right? Okay, now let me take some note points to understand these two concepts much more better way now here, right? Okay, let me take like this. Let me take some more note points now here, right? Okay, first one. Now, if I'm considering about this, right? Let me consider a body is moving in a direction which I have given here. Let me take like this, right? Okay. For example, a body is here and it moves towards east, right? It moves towards east for about 4 meters. Let me take like this. Okay, 4 meters it moves towards east now, right? Then perpendicularly it moves towards north 3 meters, right? Let me call this as initial position A, this is position B, and this is the final position where it want to reach, that is C now here, right? So this is A, this is B, and this is C, right? A person travels from A to B, then C. Okay, this is what actually is happening now here, right? Come on, tell me, what is the path length? Path length. What is path length? Path length is AB plus BC. What is path length? Total distance traveled by a body from initial position to final position. Which is this position? This is initial, and this is what now here? Final, right? So what is path length? Path length is total distance AB plus BC, right? How much do you get? AB is 4 meters, BC is 3 meters. How much do you get here? That is 7 meters, right? What is path length? 7 meters, right? Okay, by this example, you will understand what actually the difference is. If I want to calculate what is the displacement, what is displacement? It is the shortest distance. Shortest distance is always a straight line, right? Okay, let me take, this is the shortest distance, right? What is displacement? Displacement does not depend how actually you travel, right? So that is the shortest distance. What is shortest distance? AC, right? How much is AC? We can calculate it, right? If it is 4, if it is 3, what is this? As it is a right angle triangle, we have Pythagorean triplets. I think you heard about it. 3, 4, 5 are called as Pythagorean triplets. Or you can find what is this distance by Pythagoras theorem, right? How do you find? That is square root of, right? Some of the squares of the other two sides, right? That gives the hypotenuse, right? How much do you get now here? 4 square 16 plus 9, that is root 25, that is 5 meter, right? We can calculate by using Pythagoras theorem, or you know that there are Pythagorean triplets. If it is 3, if it is 4, this is how much now here? 5 meter. So what is the displacement? Displacement is 5 meter. So do understand, path length is 7 meter in this case, displacement is 5 meter in this case, right? Do you understand this, right? And sometimes these two may be equal. When they will be equal? If a body travels in a straight line, right? Okay, let me write about this. Displacement is same as path length. Displacement is same as path length if a body travels in a straight line path no, right? If a body travels in a straight line path, okay, displacement is same as path length if a body travels in a straight line path, right? If at all the body travels like this, right? If a body travels from A to B now here, right? If this is A and this is initial position and this is B, if a body travels like this and it is 5 meter, what is the path length? 5 meter. What is the displacement? Yes, since it is traveling a straight line, that must be displacement, right? So both will be same if a body travels in a straight line. Do remember, if a body travels in a straight line, the path length and displacement both are same here, right? Okay, do remember this. Displacement is same as path length if a body travels in a straight line path. If it is not traveling, right? Okay, let me take in general way. What is the path length? Path length, do remember, it is always greater than what we say here, displacement, because it is displacement is the shortest, right? Path length is greater than displacement, or it may be equal to also. As displacement is positive or sometimes it is negative, let me take modulus. Modulus means if it is negative, it becomes positive here, right? So do remember, path length is always greater than or equal to what we say here, displacement. So in general, it will be greater than the displacement. If a body traveling in a straight line, then they may be equal. But do remember, displacement cannot be greater than path length in any situation, right? So that's why I'm taking the modulus now here, right? So path length is greater than or equal to what we say here, displacement. Right, okay. Now, I had left with one concept there, when the displacement will be 0, right? Okay, let me tell about that. Displacement is 0. Displacement is 0 if a body, right, if a body travels and comes back to the same initial position, right? If a body travels and comes back to the same position here, right? Okay, if a body travels and comes back to the same position, comes back to the same position, right? A displacement is 0 if a body travels and comes back to the same position, right? Means initial position and final position is same here, right? For example, this is the initial position. It travels and comes back to the same position. So what will be the initial position? A. What will be the final position? A. Then what is the displacement? 0, right? So displacement is 0. Is path length 0? No, because it has traveled. If it keeps one step also, the path length is considered now here, right? So do remember, if it travels and comes back to the same initial position, then what is the displacement? Displacement is 0, right? If you move forward, displacement is positive. If you move backward, displacement is negative, right? If you move and come back to the same place, then the displacement is 0, right? Do remember, displacement is a vector quantity. It can be positive, negative or 0, but path length is always positive here, right? Okay, since it is a scalar quantity, right? Displacement is 0 if a body travels and comes back to the same position. And lastly, you need to know what is the direction. Direction of displacement is from initial to final position. Right? What is the direction of displacement? It is from initial to final position, right? If initial position is this way and the final position is here, what is the direction of displacement? The direction of displacement is in this direction, right? If initial position is here and your final position is here, then what is the direction of displacement? Direction of displacement is here. Means the direction of displacement is always from initial position to final position, right? So do remember, so these all are some of the properties of path length and displacement, and you need to identify what is actually the difference, and you need to know these two physical quantities. One is path length, or it is also called as distance covered or distance traveled, and another one is displacement, right? So understand these two concepts clearly now, right? So today we have studied two physical quantities. One is path length and another one is displacement. In the next session, we will be learning other two physical quantities. One is speed and another one is velocity, that we will be seeing in the next session. So before that, be clear with these two physical quantities, path length and displacement. Thank you.